Hello everyone, welcome back to the channel. I hope you guys are doing really well, and let's see today's daily challenge on Leetcode and we will try to solve it together. So today's challenge is a pretty interesting one. So let's see, let's try to understand the problem statement at first. Count the number of trapezoids 2. You are given a 2D integer array points where points of I is something like xi, yi represents the coordinates of the points on the Cartesian plane. Return the number of unique trapezoids that can be formed by choosing any 4 distinct points from the points, and trapezoid is a convex quadrilateral with at least one pair of parallel sides. Two sides are parallel if and only if they have the same slope. I hope you know these definitions. So what is a trapezoid? I will again just tell you so that things becomes very easy for you. So it is a type of quadrilateral which at least one side parallel. So you see this is a quadrilateral with this side is parallel to this side. So we have this as a trapezoid, okay, and at most any sides may be parallel. So of course a square, a parallelogram, rectangle, anything, all of these things are trapezoids, okay, and even something like this is just a, so you see if this is parallel to this, okay, so everything you see is a trapezoid with at least one side parallel and at most both sides parallel, okay. So this is how we understand what is a trapezoid, and you will be given some points. So what you will be given in the question is only a vector of points, okay. So from those vector of points you need to identify what are the how many trapeziums are there, okay. So how to approach this problem? If you have already seen my previous video, you will be, this is going to be easy for you, but even if you have not, but still you can keep watching. I will explain from scratch. So let's say you have some points like this, 1 point, 2 point, 3 point, okay. So you have this point which is lying in a single line, okay, and let's say you have these two more points. So what you can do, definitely this is a type of trapezium which you can create, okay. Again this is a type of trapezium which you can create. Again this is a type of trapezium which you can create. So total 3 you get over here, okay. So how do we get this number 3? You see, any from this single line we can choose any 2 points, right? So we can choose this point, or this whole point. So there are 3 possibilities of line segments from this, okay, and there is a single possibility over here. So for every of these 3 you multiply by a single possibility, so you get 3 answer, okay. So I will consider the possibility. See here the trapezium may be of any slope, right? It can be something like this, it can not necessarily horizontal, but we are just now taking the case of horizontal and trying to explain the solution, okay. Now you try to see, take this example for instance, okay. So let's say this example. So how many lines can you take from this? How many line segments can you take? There is 1, there is 2, there is 3. Same for this one, right? 1, 2, 3. So 3 line segments here, 3 line segments here, and here you get only 1 line segment, okay. So what you can do, using these two pairs of slopes, so this is a line and this is another line. So using these two pairs of lines, you can create 3 into 1, okay, as I had explained you here, these many number of trapezoids, okay. Similarly, using these two interactions between these two lines, you can create another 3 into 1, okay. Now if you try to consider the interaction between this hole and this hole, so this can also be a trapezium, this can also be another trapezium. So 3 into 3 you get again, right? You get 9 and you get here 3. Total answer will be 6 plus 9, which is 15. So that's how you get. Now if you try to see that what is the pattern over here, what exactly can you call as the pattern over here? You can see that if this has a line segments, okay, there were 3, a was equals to 3. Let's say this has one line segment, so I will call it B. Let's say this has again a line segments, but this I will call it C, okay. So how exactly did you calculate? The interaction between these two lines is given by A into B, the interaction between these two lines is given by A into C, these two lines is given by B into C. So AB plus BC plus AC. Okay, so this is how. And if you see, there are, let's say, n number of such lines. Okay, if you see that there are n number of such lines and many points are over here. So number of line segments that you can form, let's say A1, A2, A3 all the way till AN. If you try to form that, it will be the summation of AIAJ. Okay, so every two pair combination you can take. So I hope you are not getting confused by this thing, summation of AIAJ. It simply means that twice summation, one is for I, one is for J, and AIAJ. It simply means that if you take for three variables, it is just AB plus BC plus CA. Every combination of pair you just need to multiply. Now I had already explained you this in my previous video. I am telling again that this you can easily get, right. See, first of all, this requires two for loops, but you can optimize it. Okay, so if you try to use, see, there is double summation, right. So it uses two for loops. Okay, but if you try to reduce it to one, you can choose to write it in something like that. A plus B plus C whole square you can choose to write. Okay, so what it will be, A square plus B square plus C square plus 2 into AB plus BC plus CA. Okay, so if you try to write this AB plus BC plus CA, what you will get, AB plus BC plus CA is nothing but A plus B plus C whole square minus A square plus B square plus C square whole divided by 2. You can write it in this way, right. And you see, you can also derive a general formula for this. I hope you know this already. In your high school you might have read it. If AIAJ summation, this can be given by summation AI whole square minus AI square whole summation. Okay, and divided by 2. So you see, this is calculated using double for loop, but this sum and sum of squares using a single for loop you can calculate very easily, and hence this is also by just subtracting and dividing by 2, you can calculate it very easily. And unlike the last problem yesterday, we had to take modulo 1e9 plus 7, right. But here there is no such case of modulo 1e9 plus 7. The constraints are really small over here. Okay, points dot length is just 500, x and I and yi are just thousands. Okay, so here I hope you can easily tell me that hey, if you tell me that the trapezium which we are considering always have something like this, say, let's say this is the x-axis, this is the x-axis and y-axis, right. So if you give me lines parallel to the x-axis, I can always calculate without any difficulty in a simple O of n time. Okay, that is what. But here you see comes the interesting part. The slopes may be anything over here. Okay, the slopes may be anything. So you see, can you tell me two parallel sides? You know, I hope you know that two parallel sides have the same slope. Okay, so if this has a slope of m, this has the slope of m, then what is the thing which varies in these two lines? Can you tell me what is the thing which varies in this line, these two lines? Yes, you are correct. The thing which varies is intercept. I hope you know the slope intercept form of an equation of line. Hey, this was a very primary school topic, right? Y equals to mx plus c. So if m is same between the two lines, then definitely c is different. Okay, c is different. C is nothing but the intercept which we are talking about. Okay, so what we can do, you can store a map. You can map the values of, let's say, slope to intercept. Okay, so let's say you will calculate slope to intercept, vector of intercept. So why vector of intercept? You see, what I am trying to do, in a large 2D space, there can be many such parallel lines. Okay, some parallel line may be like this, some parallel line may be like this, and they can also form trapeziums, right? They can also form trapezium. See, there may be something like this. This is a point, this is a point, this is a point. So you are counting this line and this line. So thrice you are counting. So no need to do any combinatorics over here. So anyways, slope is to vector of intercept you are trying to store. So what exactly that will give you? It will tell you that for this particular slope, I have this intercept and this intercept. Okay, so there may be duplicate values of this intercept also, but it definitely tells you that if you select any two of them, if you select the combination of any two of them, it will give you a valid trapezium. Okay, it will give you a valid trapezium. So basically for every slope you store all of the possible intercepts. So let's say this is a slope, this is this particular slope has some line segments. Okay, so let's say this slope is, let's say, x or m I will call. Okay, let's say this has intercept c1, this has 3 line segments, 3 of them has intercept c2, 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 this has intercept c3. So in the vector, in the map, what we will store, this particular slope will have an intercept c1, c2, vector of intercept I am storing, right, as I have told you, this c3 we will store. Okay, so that is how we will keep track, and if something has different slope m dash, it will have different intercept also. So when we are iterating, we can just iterate through this map, and individually we can calculate for each slope. So you see, for when we were calculating for the horizontal case, okay, for the horizontal case, when we are calculating these many trapeziums, we were taking that, assuming that all have the same slope. Same thing we can assume here for particular same slope. Go through all the intercept and apply the exact same formula, right? This exact same formula you are now eligible to apply. So you can also tell that this is applicable for a common intercept, for a common slope, sorry, for a common slope. So there comes the idea that if this is applicable for a common slope, right, what do I mean by common slope? See, this has all the 3 lines which are parallel to each other, right? So they have a common slope. So why not group by slopes? That is the intuition. Okay, so it simply tells you, this map simply tells you group by slopes. Okay, I hope this is very clear to you, very clear to you, and you just count it at first glance. By looking at it, you might think that, hey, you are done with the problem, but are you exactly done? So you see, consider a parallelogram. Okay, so what you are doing is that at first you will calculate this as one trapezium. See, you will calculate this as a one trapezium, right? This as one, you will take these 2 points, and tell that, hey, they are both parallel to each other and they have the same slope, they are lying in the same slope, and we can count them as one trapezium, one parallelogram. Okay, then again you will tell that, hey, this is parallel to this. If I am talking about a parallelogram, see, we should calculate this whole quadrilateral once, right? But if you consider this pair of line also, it will give you another resulting the answer 2. Okay, so my total result will be answer minus the count of parallelograms, because one parallelogram tells you to count one extra value, so you do not need that extra value, so you will count the number of parallelograms, you subtract the number of parallelograms. Now there comes the idea that how will you calculate the number of parallelograms? Can you tell me, guys? Pause the video and try to think, how will you calculate the number of parallelograms? What is so special about a parallelogram? Okay, so I hope if you know from your basic geometry is that the diagonals of a parallelogram intersect at a common point, and that common point also divides the diagonal into equal parts. This is the thing. Okay, so see, at the beginning what I was doing, I was grouping by these slopes, right? For that I need to calculate slope, and I was see, I have a vector of points, right? I have a vector of points given to me in the initial question. Okay, so I am taking every pair of points, calculating the slope and putting them in this map. Okay, and also calculating the value given by this formula, right? Given by this common slope formula. So what exactly can I write for a parallelogram? You see, see, we know this property of parallelogram, that it has so when you are iterating through the points, let's say you are enumerating through these 2 points, you see, calculate that they have a common midpoint, which is this. When you are enumerating through these 2 points, okay, these 2 points, you are saying that they have the same midpoint. So you see that if two lines if two lines have same midpoint, then definitely they formed a parallelogram, right? So how you can tell this? Okay, so you see there is a midpoint of like this. You can definitely tell that, hey, these two lines, see, these are line segments, right? These are line segments. These lines have been formed, there have been at least 2 points over here, okay? Then only, so you can say that, hey, this is a parallelogram. Now there can be multiple points from over here, okay? Let's say there can be something like this, and you can also say that, say, this will also be parallelogram. No matter how many points will pass through this will also be parallelogram, and everything which is passing through a single point will be a parallelogram. So in this case, so there can be multiple values also, right? So there can be this point, and let's say this point. So in this case you will get this line segment, this line segment, this line segment, all of them have something like this, and they can form a parallelogram, okay? So I hope you do get it. And why not, see, why not now group by points, group by midpoints, okay? So you can easily group by midpoints, and you can keep a midpoint comma vector of slope, midpoint comma vector of slopes. Why you will keep this? Hey, you will ask me, why vector of slopes? You see, if there is a midpoint of this line has a slope of m1. Now definitely if this is a midpoint of some other line which has a different slope m2, you can tell that, hey, I have got one value, one parallelogram, okay? I have got one parallelogram with me, please help me find it, okay? So you will tell something like this. Now the same midpoint, this same midpoint may be housed to multiple vectors, right? In this case, this can also be a parallelogram with this, okay, something like this also. So yeah, that we will see, those things we will take care later during coding. So I hope the initial approach or the idea is very clear to you, and you can apply something like this, something very similar to this, what we used for the slope intercept. You can also use that here, okay? Yeah, you can use that here. And why exactly? Because you see, if you get two line segments over here, so what I'm trying to say is that for a point, for a particular point, you see, you get one line segment, you get two line segment, okay? Now with another slope you get one line segment, okay? Now this particular line segment can form a parallelogram with this one can again form a parallelogram with this, so 2 into 1, okay? That is what. So what I'm trying to say is that if you had got this line segment again and more another line segment again with the same midpoint I am talking about, so you have got 3, okay? So each one of these 2 can form another with this 3, so 2 into 3. Same you can form with this, let's say 1 2, so 2 into 3, again 2 into 3 plus 2 into 2, interaction between these two, and same way, right? This exact same way you can tell me, right? So if there are a, b and c points, if there are a, b and c points in this, so let's say there are, this is known as 1, this is 2, this is 3, a points, b points, c points. Similarly you will get how many parallelogram? AB plus BC plus CA number of parallelograms, and you can use the exact same formula, which you did to calculate for slope. So if it is getting too much for you, I will try to start coding, okay, and then it will be very simple and easy to follow also, okay? So I will do the initial things first, okay? I will do the first things first, that is create this maps, these two maps, okay? So let's try to quickly do those. So I have something like integer n, which is number of points, okay? Very simple, very easy. Now I have an unordered map. What is my first unordered map? It will give me slope intercept, okay? So I had already explained you this, so this will be slope. I am keeping the map in a map names in a very easy format so you can understand. So it is slope and this is nothing but a vector of intercepts. Okay, that is how we are going to group. That's what we decided, right? Group by the slope value, and then we can easily calculate whatever we need from this. Okay, from the similar slopes we will apply this formula. And again we have the midpoint to slope. So unordered map, another unordered map. We have midpoint to slope. Midpoint can be an integer. I will tell you why. And float. Okay. And this is, I will call it midpoint to slope. Okay, midpoint to vector of slopes. So that's how these are the two maps. These are the two data structures which we talked about. And you can first now iterate through all the points. Okay, so you have I less than n. You have x1, y1, x2, y2. Those things you just calculate. So x1 is nothing but points of I 0, and y1 is also simple. It is nothing but points of I 1. Okay, and you have another variable j. You can go through I plus 1. Do not take repetition of points. Okay, just select a pair of unique points everywhere. So j I plus 1 less than n, and I will take x2 y2 over here also. So points of j 0 is x2 and y2 is also simple, points of j 1. Okay, so you have these things with you right now. And to calculate the slope, let's calculate dy by dx. Okay, so dy, I hope you know this, dy is nothing but y2 minus y1. So it's very simple, as simple as that. And dx is nothing but x2 minus x1. Okay, so now comes the very interesting part, calculating the slope and intercept. Okay, so let's have float for these, float of slope and intercept. Okay, we will calculate that. Now you see, you know, I hope you know these already. If there is a line and there are 2 points x1 y1, x2 y2, right? What is the intercept? What is the slope? y2 minus y1 by x2 minus x1. So that is only I am storing it in dy by dx format. So dy is nothing but this, and this is this. Okay, so that's how I stored. But see, this denominator can be 0. Okay, this denominator can be 0, which will make this whole thing infinity, right? But do we need to ignore such lines? Answer is no, we do not need to ignore. Why? You see, you consider a slope, a line with infinite slope. Okay, this is a line. Why we will not consider this? Because there may be a trapezium from here also, right? There may be a trapezium I am getting through this. So I cannot ignore these lines with infinite slope. Also the slope is infinity here. So let's say keep an infinity value. Let's say tell that the infinity value is nothing but 1 in 9, or let's say 1 in 9 plus 7, something like that. Even if 1 in 9 you could have kept. Okay, so slope, for slope infinity also we need to take account. And what is the value of intercept? You see, you know y equals to mx plus c, right? From the basic mathematics you have run. Okay, and this much also you can know that if there is a point, another point x1, x1, y, you have studied the 2-point form in your high school. Okay, 2-point form, you can just google that out. This is also the equation of a line which you can write. Okay, so it tells you that y minus y1 by x minus x1 is nothing but y2 minus y1 by x2 minus x1, which in our notation is same as dy by dx. So that is what. And how you get this? It's very simple. You just calculate the slope between these two. This slope and this slope are equal to each other, right? So this slope is nothing but this, and this slope is nothing but this. Okay, you just equate them and you get the equation of a line. If you try to find this c value, this intercept value, then you need to solve this. Okay, so let's solve this. So let's cross multiply these two. We will get y minus y1 to be nothing as x minus x1 into dy by dx. Okay, and you can simply rearrange this to write y equals to x dy by dx plus y1 minus x1 dy by dx. And if you just write this in something a by b format. So see, this is y equals to mx plus c. If you try to compare with mx plus c, you get y, you get this is value as m and this whole value as c. Okay, so I hope that is clear. This is nothing but m, this is nothing but c. So c value you can choose to write it as y1 dx minus x1 dy whole divided by dx. So a by b format, if you try to write, this will be your formula for intercept. Okay, and what is the intercept when the slope is infinity? It means that, see, if dy by dx is infinity, tends to infinity, it means that dx by dy tends to 0. So if you try to just invert this, if you try to just invert this whole equation and equate to 0, you will get x minus x1 by y minus y1 is equal to dx by dy. Now if dy by dx is infinity, dx by dx by dy is 0, and you get from this, you get x equal to x1. I intuitively also you can tell, right, if this is a slope, this is a slope of infinite line, x1 is the point here, so x equal to x1 is the line over here. Okay, so that's what. And if the slope is infinity, so basically if dx equals to 0, okay, so if the slope is infinity, if dx equal to 0, it will mean that your slope is infinity and your intercept is x1, just now we said. Okay, else your slope is dy by dx and your intercept is this c value which you calculate, right? Intercept is this c, this whole c over here. Okay, so that is what you need to write it down. So yeah, after all of these, you can tell me that if dx equals to 0, it definitely means that the slope is infinity. So I will, let's say, call this infinity 189 plus 7, and this intercept is x1. Otherwise, we have different slopes and intercept with us, right? So this slope will be float of, just calculate the float of dy by dx. It's simple, slope is simple, right? But what is the intercept? We calculated it just now, right? So that will be float of this y1 dx minus x1 dy. So y1 dx minus x1 dy whole divided by dx. Okay, that's how we calculate the slope and the intercept. And after you are done with this, you can just simply have this slope intercept map. Okay, so what do you do for this? Slope intercept of this particular slope, you just push back this intercept, okay, as it is a vector of intercept. I hope you are not getting confused. And yeah, and if you see, now calculate the midpoint to intercept. Okay, midpoint to slope. Now there comes another thing for this, is that I hope you know this very easily, that if there are 2 points x1 y1, what is, and x2 y2, what is the midpoint? Midpoint is nothing but this, right, which is x1 plus x2 by 2 comma y1 plus y2 by 2. Okay, so you see these are the scalar parts. Okay, so for all, see, no matter what x1 y1 or x2 y2 or x3 y3 whatever is present, midpoint will always be scaled by 2, so you can remove the 2. Okay, you can, when we are hashing the values, right, you are doing a hash map of midpoint to slope. So for that hash value, you can just remove the 2 and you now have something like x1 plus x2 comma y1 plus y2. But hey, this is not a single integer with you, right? This is not a single integer with you. This is a whole new thing. So how to convert that into a single integer? So you know that the range of these x and y is 1000. So even if you add them, they cannot be greater than 10,000. Okay. So if you try to store something like x1 plus x2 multiply by 10,000, you are scaling each and every midpoint by this, so it will not make an effect. Okay, so why exactly this? how do I explain you this? So you see, let's say x1 plus x2 is 64 and y1 plus y2 is, let's say, 242. Okay, how will you store this is that 64 you store here, 0, 242, you store it in this way. You store it as a single integer. That's how you can map, and you know that it will never exceed this 4 digits. It will never exceed this 4 digits, this y1 plus y2. So no matter what be the case, so suppose you want to store the pair 565 comma 492, it will be same as 565, then you have 4 zeros and plus 492, so last 3 zeros will be 492. So you are always able to store this x comma y pair. That is how, this is a trick, you can say, call this a trick to store a pair into an integer. So you have a pair, but if you want to store it as integer, this, the condition is that definitely this pair must be in the range of 1000 or let's say something else. So you can store it in this way. Okay, so you can map these values. Okay, so midpoint, if you try to see what will be the midpoint, I can call that x1 plus x2 into 10,000 plus y1 plus y2. Okay, this will give me the midpoint. Yeah, I have scaled it, but each and every value will be scaled and our hashing will have no effect. Okay, now I can just call this midpoint slope. So midpoint slope is the map which stores this midpoint with you. Okay, so it stores this midpoint and it pushes back every slope, so it is a vector of slopes. Okay, so I hope it is not difficult at all, and yeah, you did understand this very easily. And now you have created these two maps, and then now the work is very simple with you, right? Now the work is very simple. What you need to do, you have already grouped by slopes, grouped by midpoints. Now for you see here, for the same slope, you just calculate, apply these formulas. Okay, you just calculate the sum of every pair AB plus BC plus CA. So how you can do that? You can do by square of sum minus sum of square by 2. You can easily calculate that. I hope I had explained it over here. So this is applicable for a common slope. Yeah. So what can I do? I can first have a for loop. Okay, for loop which will go through the key value pair of this. So it goes to slope and vector of intercept. Okay, so I have this with me, slope and a vector of intercept with me. Okay, and if this vector of intercept, you see, so I am looking at a particular slope right now. Okay, so this slope, this is the same slope, so I am looking for a particular slope. Now if there is only a single point, if there is only a single point or single line segment you have with you, then you do not need to do anything, right? You cannot count anything extra, because hey, let's say this is the thing and there are no parallel lines, you cannot form any trapeziums with that, right? So if vector of intercept dot size is 0, just simple, right? You just continue, you do not have anything to add to your answer. Okay, you have your answer with you, which is over here 0. Okay, you have it. Now what you do the exact same thing. First you group by the you have grouped by the slopes, right? Now you group by the, see, when you had the same slope, what do? When you do at the same slope, you grouped by the y coordinates, right? You say that hey, these many points are there in the y coordinate of this, this and this. Same thing you can do over here. Okay, so what you can do, you can have another unordered map of float comma integer. Okay, this stores the count. Now for auto in this vector of intercepts, so I hope you are not getting confused. Okay, if you have not done the last problem, you go and visit my last video for the last daily challenge, yesterday's daily challenge, and I hope from here it is all the same. Okay, it is all the same instead of sub problem and much easier. So auto float, not auto, I will call it float of intercept. I will take an intercept from the vector of intercept and just store its count. Okay, how many times that intercept is occurring. So it is the same thing, right? So I'm just calculating how many points are there. So as I had explained you, like 3 1 3. So this is a line segment, this is a line segment, this is a line segment. I had explained you in my problem, right? So I am just telling you again, so that you don't get confused. 3 1 3, if it is there, you are storing, you are calculating these three values. Okay, this has the same intercept, this has the same intercept, this has the same intercept, also the slope is definitely same. So yeah, that is what you calculate the intercept, store the count of the intercept. Okay, and what you can do after this is very simple. You have let's say long sum with you and sum of squares. Okay, sum of squares, and yeah, how you need to calculate this sum, it is sum and sum of squares, you just need to calculate. Okay, so you can go through this map right now. Let's say key comma value pair of this count map. Okay, and you are having the value directly, so you just calculate sum plus equals to v. For sum you just need to add it, and for sum of squares what you need to do, sum of squares you just need to add v into v. Now if the values are long, you might have to typecast it before adding, because v itself is an integer. Okay, so you just typecast it to long, and that is all. You will have a result also with you. Okay, so long result is nothing but this sum square, sum into sum, minus sum of square by 2. Okay, so I hope this is actually not difficult to understand. This is the same formula which I have just applied right now. And since I am doing a multiplication over here, see, I did a multiplication over here, I typecasted it to long, I did a multiplication over here, I need to again typecast it to long, and this result I will add to my answer. Okay, and see, for the midpoint thing I will do the same thing, but I am subtracting the parallelograms right now. Okay, so added all the results and subtracting parallelograms. Okay, parallelograms. Right now I will subtract the parallelograms. How I will do it? Exact same thing, I just copy paste, and you see this is the map, right? I did not write the map only. So slope intercept, this is the map which you are iterating through, and this consists of the midpoint slope, the next map which we are iterating. Okay, so intercept. So I can just press alt and just change it together. So it's nothing but vector of slope. Okay, you can call it vector of slope, and from this it is nothing but midpoint slope, midpoint to slope. And if this vector of slope is 0, you just have the same thing, and instead of intercept I will call it slope. I hope that much is trivial. And I do the same thing, and instead of adding I subtract the parallelograms, the count of parallelograms I just subtract, and I just simply return answer. If you are getting confused why I am doing the exact same method of calculating with parallelograms, if you remember I explained you this already, is that you have something like this. Okay, you have a common point, you have a common midpoint, and you are seeing that how many different slope values are intersecting at that midpoint, and if there are multiple lines A, B and C, you get the same kind of parallelogram over here, right? So that is what, if you got a midpoint and let's say you have these two values, and let's say you have three values over here. So this is a line, this is a line, this is a line, and this is a line, this is a line. So you have three values. So 2 into 3 you can form a total of 6 parallelograms. You can check, right? You can easily check. I hope you can understand that you can form a 6 parallelogram. Similarly, if there was another line, let's say 4, then you will have to form 2 into 4, plus 4 into 3 plus 2 into 3, this many. So if A, B, C is there, AB plus BC plus C. The same thing again you do for counting parallelograms. Okay. So I hope. Okay. Oh my God. So just let me see it. Just by mistakenly I just click the cross button. So yeah, but I am done with the coding. So yeah, fortunately the value this is not lost. Yeah, so you see we have it with us, and I can choose to submit it. First I will try to run it and debug if I see if any error is there. So vector of intercept. So I might have to change this intercepts to intercept. Okay, so try to run it. Yeah, you see we get the accepted thing. Green is not showing because of some extension, I guess. So yeah, I can just choose to close that extension. Okay, I will just reload my site once again. Yeah, you see I have this code, and if I try to run it, it will give me accepted, I guess. And if I try to submit it, am I supposed to get any error or not? Let's see. Let's have a look. I hope this should work just fine. Yeah, it did work fine, and it is 72% runtime. With the same code I had got a 91% runtime bits also. So yeah, it varies a lot, but yeah, I hope this is a very optimal solution. You do understand a simple n square solution, and yeah, there might be many things to learn in this question for you. I hope you did get to understand at least, and if you still have any doubt, you can definitely ask me in the comment section. So that's all for this video. I will meet you in the next video. Till then, thanks a lot.